All right, so number 38, you want to find for each of these functions that you see here, you want to determine if the function that's illustrated is an even function, an odd function, or is neither even nor odd. So that's what that neither means. Okay, so one of the things you got to remember is that an even function, in terms of what the graph looks like, an even function is symmetrical about the y-axis. All right, so an even function is symmetrical about the y-axis. An odd function, an odd function is symmetrical about the origin. An odd function is symmetrical about the origin. Now, don't get confused and think that if one's y-axis, the other one is the x-axis, because one of the things that you learned when you looked at those lessons was that if you have a relation that is symmetrical about the x-axis, for example, this relation here, see that relation is symmetrical about the x-axis. So if I take this part here, reflected about the x-axis, this x-axis right here, reflected by the x-axis, get that part. But the situation is this. So remember, this relation is not a function. Okay, so that's not a function. Remember, in this case, it fails the vertical line test, meaning that when my x value, let's say here is 5, there are two different y values. I get this y value and this y value. Now, obviously, I didn't draw this this relation very well, but the idea is that this is not a function. No matter where you draw your vertical line, it's going to intersect in more than one place, except right here. Okay, so that's the only place where it touches the graph at one point. But everywhere else, for each of those x values, there are going to be two different y values. So that's not a function. All right, now what we're talking about here, we're talking about whether a relation is even, odd, or neither. We're talking about a function. So first of all, it has to be a function. So that's why you don't see anything about symmetrical about the x-axis, because if you have a graph that's symmetrical about the x-axis, it is not a function. All right. So that's why you don't see x-axis here. You only see y-axis and you only see origin. Okay. Now neither means, just make sure you understand this, neither means that it's not symmetrical about the y-axis and it's not symmetrical about the origin. It can still have symmetry, but it's not symmetric about the y-axis or the origin. So if you look at 38, you see this graph of a quadratic function. So that's the graph of a parabola. All right, so the graph of this quadratic function is a parabola. Now you can see that this parabola is not symmetrical about the y-axis. So in the lessons, you saw something like this, where we had f of x equal x squared. And if you look at that graph is symmetrical about the y-axis. So here's the y-axis right here. And if I take this piece here of my graph right here, and I reflect it about the y-axis, I get this part here. So if you fold it, it's symmetrical about this y-axis. All right, so that's what we mean when we say a function is symmetrical about the y-axis. That a function is even. Even means that it's symmetrical about the y-axis. The other thing you learned was this, and this is important. You see this point right here? This point is 2, 4. Okay, and when you reflect this part of the graph about the y-axis, this distance here from the point to the y-axis is exactly the same as that distance from the y-axis um, to the upper part of the graph. Meaning that if this point has coordinates 2, 4, then I reflect it. If that's an even function and I reflect it, then the coordinates of that point is going to be negative 2, 4. So the y values stay the same. The x coordinates are opposites. Same thing here. If I take, let's say, let me find another easy point to deal with. If I take this point here, which is 1, 1, and notice this distance, same as this distance, and if I reflect it about the y-axis, the y coordinates stay the same, but the x coordinates are opposites. 1, negative 1, 1, 1, and the y coordinates are the same. All right. So that's the idea about a function being even. So if you have a point, let's use this one. If you have a point 39 on the graph of the even function, then another point on that graph, if it's an even function, better be negative 3, 9. All right. Okay, so that's what we mean by an even function. So an even function is symmetrical about the y-axis. So if you look at the one we have in part A, you'll notice that this graph is not symmetrical about that y-axis, right? Okay. In fact, remember we said earlier that a function can still have symmetry, but it may not be even odd. It would be neither. So if you look at this parabola, here's the vertex right here. The axis of symmetry for that parabola is this dotted line. So notice that this dotted line is not the y-axis. So therefore, this function here, this function, we would say neither. So it's neither even nor odd. Okay? So it's neither even nor odd. And remember, odd means it's symmetrical about the origin. Well, here's the origin right here. So if it's symmetrical about the origin, then if you have a point here, then you better have a point. If you have a point in the first quadrant, you better have a point in the third quadrant. That's related to it. If you have a point in the second quadrant, like we have here, we have an infinite number, then you better have, in terms of symmetry about the origin, you better have some points in the fourth quadrant that has a relationship with what you have here. All right, so it's neither even nor odd. Okay, and if you can look at this point here, see this point here, 1, 4, right? Remember, we just talked about the fact that if 1, 4, if this were an even function, if that was an even function, then the point 1, 4, the other point better be negative 1, 4, and that's not true. Negative 1, 4 is right here. All right, so you see that's that point here. That point here is negative 3, 4. So negative 3 and 1 are not even opposites. All right, so the number 38 is neither even nor odd. Okay, now in letter B, if you look at letter B, so notice and always look to see if you can think of is this function symmetric about the y-axis? Is it symmetric about the origin? And if it's not, then you would say neither. So if you look at this point here, this point right here, and ask yourself, if I reflect that point about the y-axis, am I going to get a point here where the x coordinates are opposites? And the answer is yes. Same thing here. If I take this point, reflect it about the x-axis, I'll get that point. I did not mean the x-axis, I mean the y-axis. I'll get that point here. And always remember that these distances here are the same. Those distances are the same. Same thing here. If I take this point here, and I'm making this up. Let's say that point is approximately equal to 1.7 comma, and then my y value is 1. Then when I reflect it about the y-axis, I should get, and you need to know this, that when you have an even function, and this by the way is an even function, when you have an even function and you reflect the point about the y-axis, the y coordinates stay the same, the x coordinates are opposites. So negative 1.7 comma 1. Same thing here. Reflected about the y-axis, I get that point. This distance here is the same as that distance. Okay, so this point right here is, let's say it's my x value is 2, and let's say my y value is a negative 1.3. Let's say, I'm sorry, negative 2.3. Then, if this is an even function, when I reflect it about the y-axis, my y coordinates stay the same, but my x coordinates are opposites. So negative 2 comma negative 2.3. All right, so this function is even. So this is an even function. So it's an even function because it is symmetrical, about the y-axis. Okay? All right, then number 3. So let's take a look at number 3, or letter C rather. So this is letter C right here. So you have this function, so you have this rational function, and you can obviously see that this is not an even function, because this, if that was an even function, then this part of the graph right here that I'm just tracing over, just a little part here, when I reflect it about the y-axis, I better get something that looks like this, and you don't, right? So there's no point. If you have a point in the first quadrant and it's an even function, then you better have something in the second quadrant, and you don't. All right. So then you ask yourself, all right, so I know it's not even. Is it an odd function? Meaning, is it symmetrical? An odd function. Is it symmetrical about the origin? So in order for it to be symmetrical about the origin, I want you to notice something. Let me go ahead and get that ruler so you can visually see what I'm referring to. So when you get that ruler, and I gave you a point here just to help you. So if you take this point right here, and see, this is the origin right here, and I take this point and I reflect it about the origin. So I take that point, so I'm going about the origin here, and I'm going to get this point here. See that? That distance from this point to the origin is the same as, see, this distance here should be the same as from the origin to that point. And the same thing here. If I take this point here, this point right here, and I reflect it about the origin, here's the origin, I reflect it about the origin right here, then that distance right here, that distance better be the same as that distance. So when I reflect that point here about the origin, I get this point here. And I want you to notice what happens. When you reflect a point about the origin, the coordinates, see, this is coordinates 1, 1, it becomes its opposites. So this becomes negative 1, negative 1. So a point that's in the first quadrant reflected by the origin goes into third quadrant. And if it is an odd function, and this is an odd function, and if it is an odd function, which it is, then the coordinates are opposites. So if you have a point 1, 1 on an odd function, then another point is going to be negative 1, negative 1. All right, same thing here. I'm making this up right here. Let's say this point here is, and let's say each of these is one unit. So let's say this is 0.8, and 1, 2, 3. Let's say 3, 0.83. Then when I reflect that about the origin, it's in the first quadrant. When reflected by the origin, it goes into the third quadrant. So that point then would be negative 0.8 comma negative 3. Same thing here. If I take this point here, right here, and reflect it about the origin, so here's the origin. So kind of do something like this if you need to. Reflect it about the origin. Then okay, here's the origin right here. Then I take this point, reflect about the origin, I'll get this point here. So basically this distance right here from the point to the origin is going to be the same as from the origin to this point here. Okay? All right. So this is an odd function. So an odd function, this is an odd function since it is symmetrical about the origin. Okay. All right. Now, so in the first three, you were given a graph, and sometimes given a graph is pretty easy to it's actually easy to determine whether it's even, odd, or neither. Algebraically, though, so you're given these functions, you're given the algebraic functions here. You're not given the graph, but you want to determine algebraically if the function is even, odd, or neither. All right, now here's the approach you have to take. Okay, so to determine algebraically, you have to compare f of x with f of negative x, whatever the function is. So if your function is g of x, you will say compare g of x with g of negative x. So basically, what you're going to do first is you're going to replace x with negative x. So you may remember in a couple of the assignments that you've done before, you had to find f of negative x. And one of the reasons you were given that at that point was because at some point in the course, you would have to determine if a function's even, odd, or neither, and you would have to determine f of negative x. All right, so let's talk about f of negative x. So first thing you're going to do is you're going to say, let's find f of negative x. And remember, on the last test, you had to determine how to determine f of negative x. So wherever you see the variable x, you're going to substitute negative x. So I get negative 3 times negative x to the fifth plus 7 times negative x, that's an x, cubed, plus 8 times negative x. Okay? And then you simplify each of those. Well, negative x to the fifth, remember any negative number, although this is a variable, any negative number raised to an odd power is still negative, right? So this right here becomes negative 3 times negative x to the fifth. So I can rewrite the parentheses like this. Plus, and the same thing here, a negative number raised to an odd power is negative, so it becomes 7 times negative x cubed. Kind of makes sense. Make sure you understand that. It kind of makes sense because if you think about negative x cubed means negative x times negative x times negative x. A negative times a negative is a positive times a negative is a negative. And then x times x is x squared times x is x cubed. So that's what you see here. Okay? So negative x to the third power, negative x to the third power is equivalent to negative x to the third in this form. And that's what this is. So this is this. Same thing here. So if I had done that 5 times, you'd have had negative x to the fifth. And then this one's easy. Positive x times a negative x is a negative 8x. Okay, now let's simplify this further. A negative 3 times a negative x to the fifth is a positive 3x to the fifth. A positive 7 times a negative x cubed is a negative x cubed. And then we have negative 8x. All right, now I want you to compare. We're going to compare f of x with f of negative x. Okay? So compare f of x with f of negative x. So here's f of x. So f of x is right here. So this is f of x plus 7x cubed plus 8x. And then here's f of negative x. And f of negative x is 3x to the fifth minus 7x cubed minus 8x. Since these are polynomial functions, it's easy to compare those. Just look at the terms. F of x was negative 3x to the fifth. This is positive 3x to the fifth. Those are opposites, right? Now remember, think of the y values. Think of the y values. So my y value would be this. My y value here when I substitute negative x is this. So notice x and negative x are opposites, right? X and negative x are opposites. The y value, compare the y value. The y value, each of those terms are opposites. So each of those terms are opposites. So basically what that means is that if I wanted to, I can rewrite this like this. Negative, I can factor out a negative from here. Negative 3x to the fifth plus 7x cubed minus 8x, plus 8x. And this right here is f of x. So this becomes f of negative x equals the opposite of f of x. So basically, if we go back to this idea here, remember, x, negative x are opposites, right? And then what do you notice about the y values? The y values are opposites. These are opposites, these are opposites, these are opposites. So when I go back here, remember, whenever the x and y coordinate, when I reflect it, it becomes the opposites. See, 1.7. Let's see. Oh, right here. Negative 1.7 Oops, that's even. I'm meant to go to an odd function. All right, right here. 1, 1, negative 1, 1. 0.83, negative 0.83. So whenever the x coordinates are opposites and the y coordinates are opposites, then it's a odd function. So right here, you're going to say since f of negative x is the opposite of f of x, then f of x is an odd function. Okay? All right. So first thing you're going to do with all of these, first thing you're going to do is you're going to find f of negative x. So in other words, you're going to evaluate the function at negative x. You've had experience with this on previous tests. So then when we simplify all this, we get this. Then you can compare each of those terms with what you see. Negative 3x to the fifth, that's the opposite. 7x cubed, that's the opposite. 8x, that's the opposite. Right away, you can say it's an odd function. Okay? But if you wanted to go further, you can even break it down further and explain further why it's an odd function. Because f of negative x, it turns out, see, this is f of negative x. F of negative x is the opposite of f of x. That's what this says, the opposite of f of x. All right, so let's look at part B. So in part B, we have this function. I'm going to go ahead and use another sheet of paper. So here is part B. So part B, let me go ahead and get another sheet of paper real quick. All right, here is part B. So part B is this. You have g of x is equal to 7x to the fourth plus 3x squared minus 7. All right, so if I'm going to determine if this function's even, odd, or neither, then I have to first of all find g of negative x. So we've got to compare, we have to compare g of x with g of negative x. So basically x, negative x, the opposites, okay? All right, so let's find g of negative x. So find g of negative x. So remember, g of negative x means wherever you see the variable x, you're going to substitute negative x. So I get 7 times negative x to the fourth plus 3 times negative x squared minus 7. Well, remember, a negative number raised to an even power is always positive, right? And even if you didn't know that, even if you did not know that, write it out. Negative x to the fourth means this. It means negative x times negative x times negative x times negative x. A negative times a negative is a positive times a negative is a negative, and a negative times a negative is a positive. X times x is x squared times x is x cubed times x is x to the fourth. So this right here is equivalent to this. So then I'm going to rewrite this as 7x to the fourth. And then the same thing here. Negative x times negative x is a positive x squared, so that becomes plus 3x squared minus 7. Okay? All right. So that's what we have. Now, I want you to compare, g of x with g of negative x. So here's g of x, 7x to the fourth, plus 3x squared minus 7. And then here's g of negative x, which is 7x to the fourth, plus 3x squared minus 7, right? What do you notice about those two expressions here? Those two trinomials that you have? You notice that those are exactly the same, right? So that means this. That means g of negative x is equal to g of x. So that means that when the x coordinates are opposites, the y coordinates are exactly the same. All right, well, let's go back to our idea here. Let's see, right here. So when the x coordinates are opposites, 1.7, negative 1.7, the y coordinates are what? The same. When the x coordinates are opposites, the y coordinates are the same. When the x coordinates are opposites, what'd you notice about the x coordinates are opposites? What'd you notice about the y coordinates? Each of those terms are the same, so that means that the y coordinates are the same. So therefore, this is what you're going to have here is going to be an even function, this idea from this one. So you're going to say since since g of negative x equals g of x, then, now remember you're asking about this, you got to say g of x. So you're going to say g of x is an even function. Okay, g of x is an even function. So at this point, you're comparing the opposites of x, and then you're comparing the y values, values. So when x are opposites, when your x coordinates are opposites, and your y coordinates are opposites also, then it's an odd function. When you look at the opposites of the x coordinates and it turns out that the y values are the same, it's an even function. Okay? All right, and then finally, let's look at c. So c, we have this function for c. So in c, we have h of x is equal to 2x to the 7th minus 2x cubed plus 5. All right, so again, you're going to compare h of x with h of negative x. All right, so remember, there's the work. You got to do this algebraically. So let's find h of negative x. Find h of negative x. So where we see the variable x, I'm going to substitute negative x. So I get h of negative x will be 2 times negative x to the 7th minus 2 times negative x cubed plus 5. All right, so you have to show this part. I need you have to show this part to get all your points. Same thing here. So this right here you must show. You must show. This right here you must show. This right here, you must show. I must see you substituting negative x in place of x. I need for you to say f of negative x equals this. You have to show that to get all your points. Okay, so now let's go ahead and simplify each of these. So negative x to the 7th means the same thing as saying negative x to the 7th like this. Okay? Negative x cubed, remember, again, if you have to write it out, then make sure you write it out. We've already done that, right? Negative x cubed means negative x times negative x times negative x, which is this. So this in parentheses can be rewritten as this without parentheses. So this becomes minus 2 times negative x cubed. So I wrote this like this now, okay? And then plus 5. Now, 2 times a negative x to the 7th is a negative 2x to the 7th. Negative 2 times a negative x cubed is a positive 2x cubed, and then plus 5. Okay, once you find h of negative x, and by the way, you have to show this. Okay, so you can go from here to here. You don't have to put this intermediate step, but I need to see this and this. I need to see this and this. Your final function when you substitute negative x. Okay, then you get to compare now. So now let's compare. Okay, so let's compare. All right, so h of x is this right here. So that's 2x to the 7th minus 2x cubed plus 5. H of negative x is this right here, negative 2x to the 7th plus 2x cubed plus 5. Okay? And the question is h of x, is this function here, h of x, an even function, an odd function, or neither? All right. So the x's are opposites, right? Now let's compare the y values. Are the y values exactly the same? Obviously not, right? Because this one's 2x to the 7th, this one's negative 2x to the 7th. So this term automatically says that the y values would not be the same. So since the y values are not going to be the same, then it's not an even function. Okay, let's now look and see if it's an odd function. Are the y values opposites? Okay, now listen carefully. These are opposites, right? These are opposites, 2x cubed, negative 2x cubed. But these are not opposites. 5 and 5 are the same terms, right? So in order for you to say that those y values are opposites, then every term its opposite has to be here. And that's not the case here because of this right here. All right, so you're going to say since h of x does not equal h of negative x, h of x is not even. Okay, since h of x does not equal the opposite of h of x, then h of x is not not odd. Okay, and so you're going to say, so therefore h of x is neither even nor odd. Okay, neither nor odd. All right, and that's it. So that's how you're going to determine algebraically whether a function is even, odd, or neither. And the one you're going to see, the one we're going to deal with, will all of those will be polynomials. So it'll be a little bit easier for you to deal with. But remember what you need to show. You have to show this part here, and then this part here, and then you got to make a comparison. Same thing here. You got to show that you're finding g of negative x, simplify, and then make a comparison. Tell me why it's even, odd, or neither. Okay? All right. And so that's it. So that is the key to problems 38 and 39.